Hi, everybody. I wanted to go through a couple of things on this exponential growth worksheet here. Reminder that you have a quiz on Friday over this topic. So I wanted to make sure we were all on the same page with this before you got into that. Anybody who has turned in this assignment should have gotten it back from me with comments. If you have any questions on those comments, feel free to ask, call me, text me, email me, leave a comment in the actual assignment. I will make sure to get back to you in a relatively quick fashion so that you can be prepared for that quiz. You do not need to then resubmit the assignment because I've already given you the 5 points credit for it. So if we take a look at a couple of things on here, first of all, problem number one. Remember, with all of these, use the box as your guide. All of these are what are called exponential or percent growth problems. So it's telling you that all the rates are increasing. If it's increasing, that means it's going to be greater than 100%. So you have to add the rate to 100% before you put it into the exponential equation. So for the first one here, in 1985, there were 285 cell phone subscribers in Centerville. The number of subscribers increased by 75% per year in 1985. Well, remember, these equations are always of the same form. Y equals A times B to the x power, where A is the initial value. So in this case, the initial value is the 285 subscribers. But in this case, it's different than what we were doing last week because now, since it's percent growth, it's increased by 75%. I'm going to take this off to the side over here. I know that it's going to be greater than, so I got to take 100% plus that 75%. This gets me 175%. And then I have to convert that into a decimal. Well, the way I do that is I take 175. I know the decimal place is right here. To convert to a decimal, I move it 2 places over to the left, which gets me 1.75. So that's the number that actually gets put inside parentheses, and that's raised to the x power. For problem number two, then, it says find the number of cell phone subscribers in Centerville in 1994. Well, that is 9 years after 1985 when it was first recorded. So we'd plug 9 into the exponent, and we would clean that up using a calculator. How about for numbers 3 and 4? For 3, got to be careful here on this one because it's 4%. And a lot of common mistakes that students will make with this one is that they'll go with 104%, 100% plus 4%. We know that's 104%, but a lot of students make the mistake where they just put 1.4, and you definitely do not want to do that because that would be an increase of 40%. So you've got to make sure when you move that decimal place twice, it's 1.04 that goes inside parentheses. So y equals, they said it gave us $100 initially, so that goes there, times 1.04 raised to the x power. The value is 30 years, so that's what gets plugged into the exponent. You'll clean that up. How about 5 and 7? Now, this one, we got to be careful. This one refers back to the stuff that we were doing last week, because in this case, it's not a percent growth problem. It says it actually doubles each and every day. So again, this one is going back to what we were doing last week. We'll go green this time. Y equals, the initial amount was 500. It doubles, so our growth factor is 2 raised to the x power. After 1 week equals 7 days. So we plug 7 in for there because we know that it's days because it says back here that it doubles each day. We plug 7 in and we clean that up with a calculator. Number 7 and 8. This one is increasing at a rate of 2.5% per year. This is a good one to take a look at because 2.5% is going to throw another little wrinkle into things here. If I take 100% off to the side plus 2.5% off to the side, that gets me 102.5%. Again, a lot of students will get caught by putting 1.25 here. It's not. When you move that decimal place twice, it's 1.025. That's what goes inside parentheses. So the initial rate, or the initial amount, was 185,000. We put 1.025 inside parentheses, raise it to the x power. It's 25 years, so that's what gets plugged in there. The next one, number 9, $20 is being added per hour. Since it's being added, not multiplied or divided, this is a linear growth problem. This is not exponential. So it's y equals mx plus b, where b is the initial amount and m is the amount that's being added each hour. So in this case, the amount that's being added is 20. The initial cost is 50. There's my equation. If it takes 3 hours to complete the job, we plug 3 into there and we clean it up. Finally, last but not least, is number 11. The context of this situation, what's it mean? The number 500 mean? So we're taking a look at the equation here. Y equals 500 times. So this one's the exact opposite of what we've been doing, because what we've been doing is I've been giving you the information and you had to write the equation. Now I'm giving you the equation, you got to find the information from it. Well, where is each spot in this equation? So 500 is here. That represents the initial value. By what percent is the amount of money in the account growing each year? I'm going to take this number inside parentheses. We're going to go over here. 1.03 in percentage form. If I move that decimal place back 2 places to the right, that's 103%. Well, if I start with 100%, 100% plus what gets me 103%? That is the 3% growth that I'm looking for. Again, if you have questions, please let me know. Do not hesitate to ask. Text me, call me, email me, leave a comment. Make sure that you're ready to go before you take this quiz tomorrow.